Now, we already discussed when the convex lens is immersed in water, the focal length increases. The convex lens loses its lens nature when you place it in a medium of the same refractive index, and if the lens is placed in a medium of higher refractive index, the nature changes. Convex will behave as a concave and concave will behave as a convex. Now, what if the radius of curvature increases? So as per the equation, as you know, R1 and R2 gives the radius of curvature. Radius of curvature means the radius of the sphere of which the lens is a part, and this is R1 and this is taken as R2. So for a convex lens, R1 is positive and R2 is negative for convex, and R1 is negative and R2 is positive for concave. Think it like this. Now, what if the radius of curvature is increased? So radius of curvature increases means the lens becomes thinner. So if you consider two lenses of same aperture. So one is thinner and one is thicker. So obviously the radius of curvature is more in this case compared to this. Radius of curvature is more in this particular case because it is a part of a greater sphere compared to this. So as the radius of curvature increases, all the three are in the denominator. So focal length also increases. So f also increases if r increases. So the lenses of greater radius of curvature, thin lenses, will be having a more focal length compared to thick lenses which is having smaller focal length. So r increases means, so our radius of curvature increases, it becomes thin, lens becomes thin, so focal length also increases. So radius of curvature decreases, lens becomes thick, focal length decreases. Now one side is made plane. See, convex lens, normally a question will be asked like this. A convex lens has a focal length of assume f some value, then you cut this lens into vertically into two different parts, something like this. The question is, what is the focal length of this particular part, or how is it related to the focal length of the convex lens, double convex lens? So when you divide the lens vertically into two parts, one part becomes plane. So when plane means the radius of curvature becomes infinity. So logically, if you use in this particular equation, 1 by f is equal to n minus 1 times 1 by r1 minus 1 by r2. So 1 by f is equal to, let it be normal glass, so it will be 0.5 times 1 by r1, and double convex means both values are same magnitude wise. So as we know, r1 is positive and r2 is negative, so when I substitute in this equation, it will become 1 by r minus 1 by minus r, because r1 and r2 are magnitude wise same, but you should take it, the sign should be the positive for r1 and negative for r2. So when you substitute, you should put minus r. So it will be 0.5 times 1 by r plus 1 by r. So it will be 0.5 by r into 2. So it will be 1 by r. Now the same convex lens is divided into two pieces, of which one side is plane. So let it will be something like this. Now r1 is there, r2 is infinity, r1 is equal to r. So when you substitute in the equation, it will become 1 by f equals 0.5 times 1 by r minus 1 by r2 is infinity. So 1 by infinity will become 0. So you have 1 by f equals 0.5 by r. Or here f was equal to, here f 1 by f was equal to 1 by r. On the other side you have the 1 by focal length, new focal length is equal to 0.5 times r. So what has happened to the focal length? So focal length is full double convex, this is plano convex. So it is equal to focal length of double convex was equal to r, focal length of plano convex is equal to r by 0.5. So it will be equal to 0.5 is 1 by 2, so 2 times r. So what has happened, the focal length has doubled. So the convex lens, a complete double convex lens of focal length f is made into a plano convex lens, and the new focal length will be 2 times f. Focal length has doubled.